Okay, so what we're going to do today is there were 2 more examples I wanted to get through yesterday that we didn't get through. We're going to do those 2 examples, and you'll have the rest of the time to work on your homework, which is over 3 different lessons. Okay, but you'll have about 30 to 35 minutes to work on it. Okay, so I'm on practice problem number 1 on lesson 12. So we are on page, what, like 96? Lena. Hurry up. So number 1 says, Priya collected 2,400 grams of pennies in a fundraiser. Each penny has a mass of 2.5 grams. Notice they kind of put that on the table for us. They drew us a table. They said this side is number of pennies. This side is mass in grams. And it told us her total that she collected was 2,400 grams of pennies, and 1 penny weighs 2.5. So all they've done is organize that information on a table for us. How much money did Priya raise? If you get stuck considering using the table, we're going to use the table. Now, best case scenario is we could find the multiplier between 2.5 and 2,400. Why is that hard to do? Paxton? It's a what kind of number? It's a decimal. What could I do pretty easily to make that number easier to work with? Reese? Well, I can't just move it over. I have to do math to move it over. What could I multiply by to make that a whole number, Brady? 2. If I multiply it by 2, I want us to show this. If it's times 2, what's 2.5 times 2, Kendall? 4.5. Think about that. So what's 0.5 plus 0.5? 1. What's 2 plus 2? What's 4 plus 1? 5. So it's 5. So then on this side, what's 1 times 2? 2. So I know 2 pennies weigh 5 grams. We're trying to keep this mental math. Can we do 2,400 divided by 5 mentally? No. What could I multiply 5 by to make it mental math to get it to 2,400, Maya? 2. By 2 to get it to what? 10. To 10. Ooh, I don't want a pen. So I can do times 2 again to get that to 10. Times 2 again to get that to 4. Now, can I get from 10 to 2,400 using mental math? Okay, let's start easy. Let's just look at the 1 and the 24. 1 times what equals 24? 24. So that's my whole number. But I have a 0 there. So 10 times 24 is what? 10 times 24. 240. So what do I have to do to my 24 to make it 2,400? Kinley? Add a 0. So then over here, I have to do times 240. Can we do that mentally? No, but we can do 24 times 4 pretty easily. What's 4 times 4? 16. Regroup. 4 times 2 plus 1. Is my answer 96? Yeah, because I did 24 times 4, and I'm supposed to do 240 times 4. So I had to add my 0. So I have 960 pennies. How much money did she raise, Kanan? $9.60. So we're going to write 960 pennies equals $9.60. Now, just to show you, I'm going to go back to what Reese said, because Reese was actually on the right track. It's just we don't think about this. If I want 2.5 to be a whole number, and I just want to move the decimal point to the right, what do I have to multiply to move my decimal 1 times to the right? Callan? Times 10. 2.5 times 10 is 25. Okay, but would that have been easy to get to 2,400? No, it should divide out whole. So you could have done 2,400 divided by 25 out to the side, and that still would have got us there. I'm just trying to get it to mental math, mostly. Does that make sense what we did? Yeah. Okay. Turn to lesson 13. Go to page 100. Page 100. What's it say? 13.2. Okay, in this lesson, what it's getting us to do is we're given information different ways and we have to be able to read it. So it's just a mixture of all the other lessons. So the other day, we saw that Han can run 100 meters in 20 seconds. If I were doing this problem, I would go ahead and do what to my table? What's missing? Labels. Are labels important? Yeah, so I'm going to go ahead and label this side meters. Oh, that's wrong. 100 meters, and this side seconds. Han wonders how long it would take him to run 3,000 meters at this rate. He made a table of equivalent ratios. So he's trying to get to 3,000. So what did he do first? Kinley? Because we were given this information, and he's just trying to get to there. So what did he do first? Okay, he divided by, how do we get from 20 to 10, Reese? Divided by 2. Because maybe he was more comfortable multiplying by 10 than he was multiplying by 20. Now, most of you would have probably gone from there to there. How do we get from 10 to 3,000, Parker? 300. So times 300. So times 300. What's 5 times 3? Anybody?
15.
15. And then how many zeros do I need to add, Avery? Hold on, we're doing 50 times 300. We're doing 50 times 300. 3, there's 3 in the problem, so we need 3 in our answer. Now, is that the way he did it? No, he then went from 10 down to what? So he would divide by 10, divide by 10. How do we get from 1 to 3,000? What is 5 times 3,000? 15,000. Did we do it the same way he did it?
No.
Is that okay?
Yes.
Yes, okay. Now, do you agree that this table represents the situation? Yes. Yes. He found ratios equivalent to what?
20 seconds. Wait.
We can just write it as a ratio, 20 to 100. Okay, we already finished it, so we already did number 2. What question about the situation does this number answer? What does that 15,000 tell me, Brady?
How fast? How many meters he can run in 3,000 seconds?
Yeah, so specifically, and I'm going to write mine out here just because I don't have enough room. It tells that he can run 15,000 meters in 3,000 seconds. Is there anything you would do to improve his table? Brady?
Quick question. Why does it say moving 3,000 meters when he was moving 15,000?
It tells that he can run 15,000 meters.
Yeah, but the title says moving 3,000 meters.
What title?
Where it says 13. Ron wonders how long it would take him to run 3,000 meters. Well, we did this wrong.
Okay, hold on. We didn't do it wrong.
Okay, we did right.
We're not there yet.
We can run 3,000 meters.
We did right.
So, Maya?
You would have to multiply the 3,000 and 15,000 by 2 to get to, no, divided by 5.
Okay, so let's go back to number 1. Parker?
Instead of 200 to 100.
Hold on, I'm not asking for an answer. Go back to number 1. Because Han did what a lot of you will do. Brady,
No, it does not represent the situation
why?
because
Well, technically it does, but did he finish it properly?
No.
So yes, he found ratios equivalent to 20 to 100, but does it get him to his answer? No, so let's add that. But I'm going to put he didn't finish. Because we found that he can run 15,000 meters in 3,000 seconds. Is all of that true? Yes. But what did it want us to, or what did Han wonder about, Bryson?
3,000 meters in however many seconds.
Yes, he wanted to find 3,000 meters. So add in a row. So again, all of our answers were correct. We just didn't have enough. The labels are important. Remember how I said that at the beginning and we labeled it? Now, his table was correct. He just didn't get to where he needed to be. He had the 3,000 on the wrong side. What math can I do? I have to build one of these up to 3,000. Kinley, which one do you want to use?
I'm going to divide it, but
Okay, we can divide it.
15,000.
Well, hold on. Let's build this one up then. Don't divide because we don't have a number to divide. How do we get from 15,000? Oh, sorry. I see what you're saying. To 300. Divide by 5? Sorry. So on the other side, let's do the math. What is 30 divided by 5? 6. And then how many zeros do I have left over? 2. So what could Han have done to improve his tables? 1, what did we add on at the beginning? Add labels. So add labels. And add what? What else did we have to do, Lori?
Add an extra set of boxes.
Yeah, add 3,000 to the meters side. I'm just going to add 3,000 meters. Now, does that answer the question that Han was wondering about? Yes, Han wonders how long it would take him to run 3,000 meters. It would take Han 600 seconds to run 3,000 meters. So he was on the right track. He just found the right answer to the wrong question. He solved the wrong problem, which is a common error for you guys. Number 5, Priya can bike, sorry, it's really going, 150 meters in 20 seconds. At this rate, how long would it take her to bike 300 meters? Did it give you a table for her? We're not going to fill out the whole table. We're going to keep it simple. Let's set it up the same. Is yours already labeled? No. Okay, let's label the top one, seconds and meters. It gives me 20 seconds and 150 meters. What are we trying to get to? 3,000 meters. So we're looking for that number. So let's focus on our big numbers. How do we get from 15 to 30, Kendall? Times 2. Okay, and I need 2 zeros in my problem because I have 2 zeros in my answer. So how many zeros do I need to add? Lori?
2.
So 150 times 200. So I need 2 total zeros in my problem. I already have 1, so I have to add 1 more 0. 150 times 20 is 3,000. What do I have to do on the left side? Times 20. What is 2 times 2? 4. If I have 2 zeros in my problem, I need 2 zeros in my answer. What is my answer? Kinley? 400 what? 400 seconds. Okay, we're not going to do Priya's neighbor 2. We would do it the exact same way. Okay? So lesson 13 is just kind of pushing it all together. We will have to look at different things, see if they did it right, see if they did it wrong. We will have to compare. If we have to compare, what do we have to do? Kendall? Get something comparable, which means you have to get them to look the same. Get them to the same number. Okay, on lesson 13 practice problems, I'm about to give you your homework. I will write it up here on the board because it's kind of a lot. But you also have about 5, 10, 15, 25 minutes to start on it. So, lesson 13, practice problems. 1 through 6. Okay, 1 through 6, some of it's new, some of it's old. Remember, the old stuff's pretty quick where it just asks for a ratio. Lesson 12, practice problems. 2 through 7. And lesson 11, practice problems. 1 through 6. Shh. Yes, it's due tomorrow. You have 25 minutes to start on it. If you get stuck, raise your hand and I can come help.